Good evening. Tonight we are going to work with the method of common bases. Things you want to be thinking about here for your ICANS. I can change the base of an exponential expression but keep the same value. That's the really cool thing about it. And I understand if two bases are equal, if the two bases are equal, then the exponential expressions are equal as well, which is super cool. We're going to get there. So as I'm looking at number 1, part A here, it says 2 to the x equals 16. The equals tells me what's on the left and the right is the same. So if I go through and think about how I can get 16, I remember that 16 has a base of 2. If I raise 2 to the 4th power, or 2 times 2 times 2 times 2, then I'm going to get 16. Now, both of these bases are 2, so that means that the numerator, or not the numerators, the exponents are what we're looking for. All right, so now looking at C. C here I've got, okay, a 4, and I have 16 to the x. We just rewrote 16 to the x as, we wrote 16 as 2 to the 4th. How could I write it in terms of a base of 4? I could use 4 squared. And then I could write 4 to the 1st. So 2x equals 1 and x equals 1/2. Now, in D, you are definitely going to have a negative, so be prepared for that. And we're going to use this to help us a bunch. First, we want to just think about how these exponents, and remember that power to a power, you're going to multiply, okay? Remember that. So right over here, this would be 2 to the 3x. This right here, negative 1 times 3x minus 7. Big thing here, guys, remember to distribute that negative. So negative 3x plus 7, and that has a base of 5. So lastly, you're going to do C, and you're going to bring that negative through. Be very careful with that. So now we're going to use this really cool trick to help us solve these. So thinking about 8 and 32. And I always want to go down to the prime factorization. If that's something that is stressful, that you're not quite sure, you want to go right to your calculator. Go to the menu. Then you're going to go to the algebra. No, I apologize. You're going to go to number, and it will give you the factors. So you can say factor 32, and it will tell you that that is 2 to the 5th. So again, menu, number, and factor. If I need to factor 8, that will be 2 to the 3rd. So here I have 2 to the 3rd, to the x, and 2 to the 5th. Now I have bases equal. First, I'm going to say, okay, 3 to the x would be 3x. Bases are now equal, so I have 3x equals 5, and x divided over will be 5 over 3. Looking at the next one, you're dealing with 9. So you're going to go menu, number, factor. Factoring the 9, 3 squared. Factoring the 27, 3 cubed. So 3 squared. Oh, this is the one you're supposed to do. Well, I'll leave you there. And then we'll come over here. And I'm going to think about 125. I'm going to factor that. Menu, number, factor, 125. And I get 5 to the 3rd. So 5 to the 3rd to the x. And then 1/25 factors is 5 to the negative 2 raised to the 4 minus x. Get myself some more space here. So rewriting these power to a power, I multiply. Watch your parentheses here. So that is going to get me negative 8 plus 2x. And over here, I still had 5 to the 3x. Now your bases are equal. You can drop those off. and you get 3x equals negative 8 plus 2x. I'm going to subtract the 2x over, and I will get x equals negative 8. All right, looking at the next example. Oh, wow, scary, stressful, all those words. But is it really? First, you have ways to break down the 64, factor that, and it's a multiple choice. Type it into your calculator exactly as you see it with the equals. Then store the different values that they're giving you. And the funky notation over here just means plus or minus 3. So you're going to start with 3, store that as x, and then check it. Then do the negative 3. If that doesn't work, then you try the 0. Then you try the positive radical 11 and the negative. So you will try this one, and you will know you have the right answer. And then we're going to go on to the next one. And you're going to look at this. And you may hate your math teacher a little bit, but overall you'll be like, thanks, that was a lot of fun. So you have two exponential curves, and they're graphed for you. And they intersect at a point A. And then they show you that you have this perfect little rectangle in there. So the first thing you have to think about is, okay, area of rectangle is length times width, correct? So you know that. And then, how would knowing the coordinates of point A be helpful in finding this area? So area, length times width. Here is the length, here is the width, right? Or vice versa. So that point right there is over this much on the x-axis. So knowing this horizontal line here would be my length, would be the x. Knowing the y value would be my width. Okay, that would really be helpful. So, to find the area of this algebraically, we need the length and the width. So what's nice about this is that even though they've left us with a big mess, I know that because they're intersecting at this point, the two graphs are going to share that point. So I'm going to set them equal to each other. So we're going to write down 4 to the x plus 5 over 2. And I'm going to set that equal to 1/2 to the 2x plus 1. And now you forget everything else about that disgusting picture, everything else of finding area, and you just look at this. And you remember, okay, common bases. I'm going to use a common base of 2. So the left side here is going to become 2 squared raised to the x plus 5 over 2. The right side already has the 2 in there. It's just 2 to the negative 1. And that's raised to the 2x plus 1. Already, I can see the common basis. Now, raise power to a power and multiply those. Be very careful in both cases. You're working with a binomial, so you want to make sure you're distributing to every single term. So I'm going to have 2x plus 5. See how the numerator and the denominator are canceling out? And then over here, negative 2x minus 1. Bases are now equal. Go ahead, set the terms of the exponents equal to each other. Add the 2x over, and I'm going to get 4x. Subtract the 5 over, and I'm going to get negative 6. So x comes out to be negative 3 over 2, which does make sense when I was looking at this graph up here, that this is in the second quadrant, that x value would be negative 3 over 2, or 1.5. We're still going. Here we go, guys. So you've got the x value. To get the y value, we have to remember that this disaster, these two functions, equaled y. So 4, it doesn't matter which one you pick. I'm just picking the one I saw first. So y equals 4 to the negative 3 over 2 plus 5 over 2. That's going to reduce to 5 over 2 minus 3 over 2 will be 2 over 2, which is 1, correct? So y is 4. So now you finally have a point of negative 3 over 2, 4. Yay! Still didn't answer the question. They wanted the area. So we know, and I'll draw the picture again down here, we have 3 over 2 was that, and this is 4. Here's the trick of extra on here. Area is something that's positive. It's a space. So you have to remember that even though the point we found was negative 3 over 2, when I'm doing the area, you would say 3 over 2 times 4, and you would get an area of 6. Now give yourself a pat on the back because that took forever, but you did it, okay? And now looking at the last one, this one is a multiple choice again. So you do have to know that if they're going to intersect, they're going to be equal to each other. But once you set them equal to each other, you can go through and start to solve, okay? When you get to the finale, you can go ahead and check your answers. So good luck with that and have a great night.